Rumor did a fish. We had as extensive a tour as this today.
This cast unloading pool. The depth of the water here is in the neighborhood of 44 feet.
615 canisters which now contain fuel assemblies, and that represents about 70% of the pool capacity.
They increased the capacity of the tank. So that's one thing to have. The management program is studying the disposal of fuel assemblies without processing them, without turning them into a high level. That won't come online. That repository is not scheduled to come online until the late
1990s. Should we have an abnormal condition occur, we would have a flash delay on the alarm panel, much the same as this, and an audible sound to determine whether or not equipment will fit the building space that we've been seeing some of these plants doing.
Okay.
That has all the chemical properties of radiation. Yes.
Similar to beer bottle glass. Or still a Cook's label out here. Yeah.
One is at Savannah River, South Carolina. One is in Idaho Falls, Idaho. And the other one is in Hanford, Washington. We selected the Idaho Falls office to double waste and tanks. So in our view, the most manage this contract for this particular activity for us, and the office, who will set up a project office here, will be helping us solve those other problems. Now, local citizens organizations, and in like manner, we hope that you will cooperate with us. Remember, we are here.
State of New York, Secretary Edwards has pledged that the Department of Energy will take into
Well, in just about 5 days, the federal government takes possession of the nuclear waste facilities at West Valley. That's about 30 miles south of Buffalo. The cleanup effort will be one of the most important projects of its kind ever undertaken in the United States. And today, top federal energy officials came to Western New York to receive some citizen input and spell out their own intentions.
We want to be good neighbors, and we want to work with you. Thank you.
Encouraging words by a federal spokesman to a group of citizens concerned about their environment. The task ahead at West Valley is monumental. Under this section of land and inside a holding tank identical to this scale model sits 600,000 gallons of high-level liquid radioactive waste. Over a period of 16 years, the federal government and Westinghouse Electric Corporation will attempt to turn this liquid waste into a solid glass or ceramic-type substance, possibly to be shipped off to a federal repository still to be designated. It will be a delicate operation, and a citizens panel led by Peter Skinner appeared to be very concerned about citizen input.
The technologic difficulties of the project, the public sensitivity of the facility, and the hazards of the undertaking all underscore the need for careful planning and public involvement from start to finish.
I promise to keep you, the community, fully informed of what we're doing and what we plan to do every step of the way. We're well aware that your help and cooperation is vital if the work is to be done to your satisfaction.
Farmer Emil Zimmerman was concerned about liability if there were an accident. Federal officials showed pictures of a similar project in Idaho, where radioactive waste tanks were emptied safely. But there was also concern about federal budget cutting. The Federal Energy Department itself is in jeopardy.
Mr. Myers, one question on everybody's mind is what happens to the West Valley project if the Department of Energy is dissolved?
There should be no effect on the project. If you recall, when President Reagan made his announcement a few days ago, he talked about dismantlement. And what that means to me is that the various functions in the department which are mandated by law or are necessary to do will be either distributed to other agencies or a new independent agency will be set up.
Similar projects have been conducted in France and in parts of the United States with success. For West Valley, it will take 16 years to complete this project. But after today's meeting, it could be said with great certainty, the federal government and Westinghouse are committed to the project.
I'd like to tell you briefly what we're going to do, but I will abbreviate it considerably because I believe that the previous speakers have told you about the various alternatives that are available in what must be done with this high-level waste. Essentially, you've heard that we're going to convert this liquid into a solid glass or ceramic material, thus protecting our air, our water, our land, doing this job with the maximum protection of our workers and of the community. The first task, as Mr. Hamrick showed, is to do the planning and the engineering necessary to begin constructing the equipment which will convert this liquid waste into a solid. The solidified waste will ultimately be shipped in metal containers out of New York to a national repository. The tank which held the liquid waste will then be decontaminated and decommissioned. The waste solidification, the decontamination and decommissioning technologies are not experimental. They've been tested and used both in this country and abroad. Westinghouse has experience in nuclear waste project management projects such as the Waste Isolation Pilot Plant, which I directed in New Mexico. We have also decontaminated a number of facilities, including the Plutonium Fuels Development Laboratory and the Materials Test Reactor. We have an experienced team ready to solve the West Valley problem safely and with existing technology. We plan to keep you advised every step of the way. I, my team, and Westinghouse are looking forward to the safe and successful completion of this important project, and we look forward to working with you and getting to know you all much better. Thank you.
We're ahead of schedule. We have more than an hour now for your questions. There's no question that this is one of the Department of Energy's most important undertakings. Millions of gallons of similar wastes await solidification at other U.S. DOE facilities across the country. The West Valley project will provide valuable experience to the department in its efforts to properly dispose of the inventory of liquid high-level waste that I've just spoken of. In addition, the risks to health and the environment which prolonged storage of easily mobilized high-level waste represent will now be addressed as research into the preferable method of solidification is undertaken. It is clear that the nation has committed itself to this imperative effort. It is absolutely necessary now that Congress assure Westinghouse sufficient funding to carry out the initial work with all appropriate speed. The NFS facility has engendered strong professional and lay opinion about the feasibility and acceptability of nuclear fuel reprocessing and waste management. We all know that. We've been through this for many years. In some ways, this facility has been the most controversial nuclear facility in the nation. Due to the high degree of local, regional, and even nationwide sensitivity to the activities at the site, it is obligatory that the project be carried out in the most open manner and with a high degree of public participation. It is projects of this kind for which the National Environmental Policy Act was written, recognizing the importance of public involvement in decisions regarding major federal actions. This act has caused the creation of the DEIS that we have before us. The technologic difficulties of the project, the public sensitivity of the facility, and the hazards of the undertaking all underscore the need for careful planning and public involvement from start to finish.
I mean, we have to make a living here. If our milk is contaminated and say they come around and say you can't ship any more milk because you've got too much strontium-90 in it, what happens to the livelihood of these people in the area? Has that been considered in this at all? And if it hasn't, why hasn't it? And I think this should be incorporated before anything else is done in this process.
All right. This is a model of the high-level waste tank in which the radioactive liquid waste at West Valley is contained. For reference, there's a man to show you the size. The scale of this model is 3/8 of an inch to a foot. Now, it consists of a mild steel tank, 70 feet in diameter and 27 feet high. It's sitting in a partial tank that is about 5 feet high, and this is called a cup and saucer design. The cup and the saucer then are sitting in a concrete vault, 2-foot thick concrete vault, and the entire vault is sitting in our silty till on 4 feet of gravel and is covered with 8 feet of dirt over top, so that the whole thing is below the surface. Outside the vault, we inject water so that the entire area is saturated with liquid. In the event the vault would crack in any way, shape, or form, the water would leak in, and then we would be able to detect it with liquid level detectors, both inside the vault and inside the pan.
Let me just interrupt for 1 second, Jim. Is there a crack in the pan?
There is a hole in the pan. There's a hole in the pan between the pan and the vault. There's no radioactivity in that liquid in there, and there's no radioactivity outside the tank.
The pan is the saucer?
The saucer, yes.
And that was supposed to be a catch basin for any leakage.
The cup and saucer, just in that concept, is right. As if you had a little spill, then it would catch here. You would catch it here, and then with transfer means pump it back into the tank. That was the concept. So it was a sort of a leak detection system. Since that has been the original system was compromised, we have since put in more sensitive systems that have been approved by the Nuclear Regulatory Commission, so that now our detection system is hundreds-fold more sensitive than the original concept, so it's not necessary.
But, Jim, that would only detect if there were a leak, right?
Correct.
So it's an after-the-fact kind of detection.
All systems were after the fact. In other words, this is why it's in the vault. Now, for that contingency, there is a 24-inch pipe that extends from the center of the tank up above grade. There is, right beside this, an empty spare tank, and there is a pump. So in the event we detected a leak in this tank, in this complex, then we would put the pump in here and pump the contents to the spare tank, and that has been in existence since day one. This tank is a result of the latest design or technology as of 1963. And so the criteria for the design of the tank was given to the company by the then Atomic Energy Commission. And it contained provisions for one to protect the integrity of the tank so that it wouldn't oscillate from heat or pressurization, and also it was heated so that it stress relieved. In other words, when you weld metal, you put it under stress, and that stress could cause corrosion if it's affected by some chemicals. And so in order to eliminate that, this tank was also stress relieved before it was used.
And one final question, Jim. We have heard everything from 2 years left in the life of this tank to 400 years. What is the extent of corrosion that you're aware of?
All right. The tank is mild steel. The waste is put in it is neutralized with caustic, and that is oven cleaner, just the same as the ladies use to clean out their oven. Caustic will not dissolve mild steel. That's why it was built this way. At the time, in the early 60s, when the government requested industry to get in the business, their experience at Hanford and Savannah River was, well, from 40, 60, 20 years. To be conservative then, there was a escrow fund set up with this tank so that as we used it, we would generate a fund to replace this on a frequency of every 50 years, and that was conservative. That didn't say that it was going to fail then, but that was extremely conservative. In 78 or 77, at the request, and this other pipe here contains what we call corrosion coupons. They're pieces of the material of the tank, both in the liquid and in the vapor space above it. We pulled those and made a study by weight of how much corrosion had occurred in from 66 to 77, or 11 and 12 years. Based on that, this tank would last another 400 years if the corrosion rate contained at the same rate, continued at the same rate.
Are you confident that that is an accurate figure?
Well, I'm, you know, I wouldn't be afraid of it. No, I wouldn't be afraid of it, and that, because corrosion, the rate of corrosion changes or increases, essentially doubles every 10 degrees centigrade of heat. That's a basic chemical principle. As a matter of fact, this tank is cooling from at that point. That the maximum temperature of this tank was 224 degrees Fahrenheit. It is now held at 185 degrees Fahrenheit, which would be equivalent to about 20 degrees centigrade. And so on that basis then, if you'd use the same principle, chemical principle, we've decreased the corrosion rate over that original by a factor of 2. So I'm confident that there's no problem, but, you know, that's just one test, yes.
Where is the tank on the plant site?
We'll show you that. We'll show you.
Show me the map just so I can get an idea.
I'm sorry.
Sludge that, remember they were talking about sludge is the bottom form. Is there concern about the waste getting stuck on, adhering itself to the columns as
that it didn't leak or that the tank didn't fail.
Now, where is it? Point to where the sludge would be if we were...
All right, now, you see these supports on the bottom. Well, they're not actually that way. That was for ease of model building. Actually, the construction is like this, where there's an I-beam sitting on supports that we call a chair structure. And there's actually 10 inches space underneath this, so that you can move through this. However, it does serve as a baffle, and therefore, if you're going in here to try to remove all the material, getting 100% of it out will be difficult.
So where, for example, where would it be here as far as depth?
What was intended initially was that the heat involved in this tank, just as the radioactivity, as results from the fission products removed from the fuel. And all fission product, just by the definition of it, is radioactive, unstable, and decays with a half-life. And so that decay creates radiation and heat. And so as it decays or cools off, the heat associated with it decreases. And so, as does the radiation. Now, if you have 100% of something today, and in one half-life you'll have 50%, two half-lives 25, 3, 12 and a half, and they go on down. So if you just do that mathematically, after 10 half-lives, you'll have 100% of the original material, whatever that radioactivity is. The principal isotopes in here are strontium-90 and cesium-137. They have, for general numbers, half-lives of 30 years. Generate equivalent to 200 gallons of liquid waste per ton of uranium. Okay? One more time, 200 gallons of liquid high-level waste per ton of solid uranium fuel, about 20% in weight. And so actually it's uranium oxide. That's how we rate these plants. And so for the boil, do you want me in it or no?
No, I'd be fine.
Yes, they say 1984 for the waste form. See, for the waste form, that's in their schedule. 1 point.
Yeah.
But you know, an awful lot of this project. You know, you guys have so much footage from helicopter flyovers. I know, I'm tired of looking at it. It's ridiculous. We need 2 shots. But you have the movie.
Yeah, the movie's scratching. It's great stuff, but it's old.
It is. NFS building, the logo there?
I'd rather do the front.
Yeah, but I mean, if you were standing there, if you were standing up, this would be the location.
Well, I'm sure we'll be in touch many times over the next few years.
See you all back there.
All right, we're going to
We're not going back.
Oh, you are?
Nice meeting you.
Okay.
Did you give me a number?
Yep.
Thanks, Jim.
I believe this agreement marks a new era for the federal government in assuming its responsibilities for dealing with this very, very difficult problem of nuclear waste disposal.
After 4 years of intensive state and federal negotiations, the West Valley Nuclear Waste Facility will be turned over to the federal government by October 1981 for a delicate and somewhat dangerous project with certain elements never before undertaken in the United States.
I want to emphasize that all work at West Valley will be accomplished consistent with the requirements of the National Environmental Policy Review Act as well as the State Environmental Quality Review Act, and will be subject to considerable involvement with the Nuclear Regulatory Commission.
90% of the $285 million project will be paid for by the federal government, 10% by the state. The Federal Department of Energy will take possession no later than October 1st, 1981. The project could last as long as 17 years, with the high-level radioactive waste solidified into a glass-like substance and ultimately removed to a federal repository for permanent disposal. Mr. LaRocca gave one more assurance today about the future of the West Valley site.
The agreement precludes the use of West Valley for any other purpose but the solidification and removal of these wastes during the conduct of this project.
The State of New York and the owners of the West Valley nuclear dump site, Nuclear Fuel Services, have struck a deal for NFS to leave West Valley. Attorneys for Getty Oil, owner of Nuclear Fuel Services, and the state agreed today on a transfer of ownership from NFS to the State Energy Resource and Development Authority. NFS also agreed to kick in $20 million to help clean up the contaminated site 40 miles south of Buffalo. The transfer of ownership could come at any time.
NFS no longer will be in possession of the center at West Valley.
The Department of Energy will supervise the cleanup operation of West Valley, with Uncle Sam picking up 90% of the tab.
It has been 10 years since Nuclear Fuel Services suspended operations at its West Valley plant. Today, the controversial cleanup of atomic waste is beginning. News 4 Special Assignment reporter Alan Costantini has the story.
We're doing something that is in the national interest. The nation has to learn how to do what is going to be done here.
The bright February sun must have seemed a good omen to federal, state, and Westinghouse Corporation officials on this first full day of control of the old NFS site in Cattaraugus County. Armed with a new name and a new policy of openness to the media, the new West Valley Nuclear Services Company happily took a couple of dozen reporters on an extensive tour of the plant, which is second only to the Love Canal as a location of concern to local environmentalists. Until 1972, NFS reprocessed the nuclear waste of the infant atomic power industry here. Then came a decade of struggle between the NFS parent Getty Oil Company and the government over the responsibility for the plant. And finally, just before midnight last night, the takeover of the facility by the Westinghouse subsidiary, West Valley Nuclear Services. 600,000 gallons of liquid high-level waste is to be solidified into a glass-like substance and then moved to dry storage, probably out west. The brown interruption of the snowy landscape is testimony to the heat generated by the waste in a giant tank beneath the surface. The trick will be to move it from the tank and into this room inside the plant. The so-called chemical cell is where the solidification process is to begin sometime in the late 1980s. How to move the CS-137 and strontium-90 has yet to be determined. Something not included in the 10 to 15-year cleanup of West Valley are the 615 aluminum cylinders here in this pool. Inside the 30-foot deep pool of water are 163 metric tons of spent nuclear fuel rods from 5 different utilities. The radiation levels there are comparable to the liquid waste in the buried tank, but no one knows yet what will happen to this solid waste.
Ultimately, that will be part of a national spent fuel program. As soon as that is developed, this fuel will have a place to go.
The program is controversial, but there is a sense of relief that something is finally being done. Alan Costantini, News 4 at West Valley.
In the news tonight, a move to further protect West Valley from any more nuclear waste was defeated today in the U.S. Senate. That defeat still leaves West Valley as one of 3 sites recommended for future storage of nuclear fuel rods. Rich Newberg has more.
Today's vote means West Valley could still be used as a temporary site to store nuclear waste from power plants all over the country. The site already houses 162 metric tons of spent nuclear fuel rods from various utility companies, including the Gunay plant near Rochester. The vote also means trucks carrying the radioactive waste would be permitted to travel across the nation's highways, delivering their loads to either the West Valley site or facilities in South Carolina or Illinois.
We're going to have incidents of carrying atomic waste over our nation's roads, which are going to cause a great deal of concern for residents in the various communities. In addition, it would possibly jeopardize and open up West Valley as one of these temporary storage sites now.
But West Valley still has some protection against reopening as a temporary nuclear waste storage site, because until 1997, the facility will be used to solidify the high-level liquid radioactive waste that now lies in containers like this one underground. Note these historic remarks made by State Energy Chief LaRocca.
The agreement precludes the use of West Valley for any other purpose but the solidification and removal of these wastes during the conduct of this project.
The bill that was defeated today would have allowed nuclear power plants to store waste on their own property and not in places like West Valley. There are many who believe reopening any site for temporary storage of nuclear waste will only serve to postpone one of the major concerns of the country, finding a permanent repository for nuclear waste. Rich Newberg, News 4, Buffalo.
Right behind me is a burial ground for 600,000 gallons of high-level nuclear waste. And right next to it is a carnival tent, complete with balloons for the kiddies. It's part of a public relations campaign to clear up the mystery behind the cleanup project at West Valley. West Valley balloons, West Valley frisbees, and free picnic food were meant to change the image of the plant, which gained notoriety through the fears of environmental crusaders. A Westinghouse subsidiary will convert the buried liquid waste here into a more easily handled glassy form. The company says it won't be permanently stored here.
No chance at all. This is not considered a suitable site for a federal repository.
Why not?
It's simply not got the geology for it. The geologies that are presently being considered are salt and some of the volcanic rocks like basalt, tuff, and granite.
Visitors were taken for a tour of the plant, where old fuel reprocessing gear will be decontaminated and removed so machinery to solidify waste can come in. We were shown robot arms that will do work in still contaminated areas. There were models of the underground tanks that hold the liquid nuclear waste, and evident throughout were radiation monitoring devices. One large water-cooled area is filled with old nuclear fuel assemblies, still active enough to heat the pool to 80 degrees Fahrenheit.
We've handled lots and lots of highly radioactive spent fuel and other materials. We've done that successfully, and it's based on that track record that I feel confident that we won't have any kinds of problems like that here.
After visitors were checked for radiation, I asked if they had changed opinions of the West Valley cleanup.
We're pleased that they opened the facility so we could take a look and see for ourselves. And apparently there are lots of health and safety measures in place, and that's very satisfying to see.
I basically found out what they do here, but just not what's going to happen after they do it.
The results of the project here at West Valley will be important, both for those who favor and for those who disagree with the use of nuclear energy, because effectively handling the waste products will be a major roadblock out of the way for a future nuclear industry. Emil Jablonski, News 4 at West Valley.
Final Federal Energy Department report on West Valley is in, and the recommendation for dealing with the nuclear waste there should please the environmental groups. The report recommends shipping the waste to a federal repository for permanent storage. The conclusion is part of the long-term management of the 600,000 gallons of liquid high-level radioactive waste at the abandoned West Valley site. The study says the preferred alternative for disposing of the hazardous material would be to solidify it into a glass-like substance and transport it to a federal radioactive waste disposal site. Well, the only problem now with that plan is the fact that the federal government still has no permanent disposal site for the waste, which can remain dangerous to human health for 250,000 years. West Valley has been shut down since 1972.
The chance is very small, but still there, that the nuclear storage site at West Valley will reopen to utilities again. A House committee last week failed to stop the U.S. Energy Department from creating storage sites away from nuclear plants. That leaves the door partly open for West Valley to reopen. Congressman Jack Kemp and Stanley Lundeen say they're getting a little bit worried.
I am utterly convinced that the provisions are inadequate to exclude those sites, and deeply concerned that the Senate will prevail and West Valley may be the most the most convenient dumping ground.
There seems to be a technical possibility that the away from reactor bill might allow for West Valley to be used. I don't think that is a possibility, but at least that technical aspect of the bill needs to be addressed, and both Stan and myself and others are going to make sure that in conference we remove any possibility of West Valley being used either temporarily or permanently as a storage ground for nuclear waste.
Kemp and Lundeen will take their concerns to the House Energy Committee and try to hold up any legislation that might reach the floor. West Valley will become part of Kemp's district in this coming election.
Conquering the rushing power of water. Releasing the energy in coal to make steam to generate electricity. Tapping deep reservoirs of oil to help meet the nation's power needs. Harnessing natural gas for industry in the home. And finally, unlocking the power of the atom. Putting the peaceful atom to work to generate electricity promises almost unlimited energy resources for today and tomorrow to meet the surging demands for safe, economical, smoke-free power. This is a spent fuel element from the reactor of an atomic power plant. Now, after 1 year in the power reactor, it is exhausted and must be removed. Not to be discarded like the ashes from a coal fire, but to have the valuable materials still inside reclaimed for future use. From atomic power plants throughout the United States and from research and test reactors, spent nuclear fuel elements in ruggedly built trucks and special railroad cars head toward western New York State and the first privately owned plant in the world, built exclusively to recover nuclear fuel for future use. The plant of Nuclear Fuel Services, site leased from the New York State Atomic and Space Development Authority, located 30 miles south of Buffalo in West Valley, New York. Here begins the story of nuclear fuel reprocessing. Reprocessing nuclear fuel is a story of mechanical and chemical ingenuity that is contributing to the rapid growth of low-cost atomic-generated electric power and promises even more benefits as new uses are found for the byproducts of this plant. Each day, Nuclear Fuel Services can process up to 1 ton of spent fuel elements, reclaiming the highly valuable uranium and plutonium still locked within them. Upon arrival, the shipping container is checked carefully in the receiving area, the superstructure removed, and the rugged cask which contains the spent fuel elements is lowered into a 45-foot deep pool of water where the top is removed from the cask by remote-controlled wrenches. This cask contains 10 spent fuel elements. One by one, they are lifted out and each placed in its individual canister, always with 11 or more feet of water between the fuel element and the surface. Traveling cranes carry each canister, still underwater, to the fuel storage pool, where hundreds of fuel elements, each in its separate canister, are stored to await the beginning of the processing cycle. To convey a single canister to the process mechanical room, 2 claws on a mechanical arm take a canister from the fuel storage pool and transfer it underwater until it emerges through a trapdoor, and the single fuel element is removed from the canister by means of remote-controlled manipulators whose operators work behind 4 feet of concrete. Mechanical processing starts here. The spent uranium dioxide fuel is located inside the long tubes that are bundled together to make up the fuel element. The tubes are of high-strength metals, such as zirconium or stainless steel alloys, which are durable at high temperatures and extremely hard. The problem is to open these tubes so that later in the process, chemicals can go to work and separate the uranium, plutonium, and fission products from the metal of the tubes. The best way to do this is by sawing off the metal ends of the fuel elements with an abrasive saw. The fuel element, now minus its end fittings, is a bundle of tubes that is charged into this magazine. Positioning the rods and holding them securely while they are fed into a powerful mechanical shear that chops the tubes into short lengths so that the nitric acid used later in the process will be able to attack the spent fuel and dissolve it from the metal tubes. The guillotine pieces then fall into a chute leading to the general purpose cell. To receive the chopped pieces of metal, a cylindrical stainless steel basket perforated with small holes and containing a thin iron liner is placed in a transfer device that moves the basket into position under the chute, ready to receive the chopped metal scraps and used fuel. The iron liner holds the metal pieces and prevents the valuable powdered fuel from passing through the holes of the basket. When the basket is loaded with chopped fuel pieces, it can be either stored in this cell or lifted into the chemical processing cell, where large tanks filled with nitric acid receive the baskets. The acid begins to chew away at the thin iron liner, quickly dissolving it, then attacking and separating the spent fuel from the chopped pieces of metal tubes. When the separation is complete, the nitric acid now contains dissolved uranium, plutonium, and fission products and is pumped out of the dissolver tanks. The stainless steel basket, which now contains only the pieces of chopped metal tubes that were not dissolved by the nitric acid, is removed from the dissolver tank and lowered to the general purpose cell for sampling to determine if all the uranium and plutonium has been removed from the chopped tubes. Representative samples are taken to a laboratory and analyzed. The remaining chopped pieces. Quality control is an underlying theme at Nuclear Fuel Services. The entire process is analyzed and monitored to guarantee that the efficiency of the system is up to required levels. For example, the dissolver solution from each dissolver batch is sampled and analyzed to establish precisely the amount and value of uranium and plutonium contained in the fuel. In this and other stages of the process, Nuclear Fuel Services chemists determine such important factors as isotopic concentration, acidity, amount of impurities, and specific gravity. The entire reprocessing operation of Nuclear Fuel Services is under centralized control from this master control room, where every part of the operation is observed and coordinated around the clock. Operators watch the process with a help hand that pinpoints every step in the cycle. Shown here schematically from arrival and storage of the spent fuel elements, sawing and chopping of the fuel elements, dissolving in nitric acid, burial of the chopped metal pieces, separation and purification of the uranium and plutonium, and shipping. The next step in separating the uranium, plutonium, and fission products is to remove the major portion of the fission products, the ashes and clinkers of atomic fire, from the solution that has come from the dissolver tanks. This is done by means of a selective extraction process. The scrub liquid literally blots up the fission products and removes them through the bottom of the tank. The fission products are concentrated and then buried in large and deep underground waste storage tanks under state and federal regulations. The remaining solution, containing the valuable uranium and plutonium, both with lingering traces of fission products, is pumped to another operation where a process called selective reduction takes place. The uranium and plutonium are separated into two streams, and both streams then undergo further treatment to remove the last traces of fission products. To rid the plutonium of any lingering traces of fission products, it is passed through an ion exchange bed, which literally holds the plutonium in the bed and allows the remaining fission products to pass through. Regeneration of the ion exchange bed recovers the purified plutonium. Uranium also undergoes a further purification step by passing it through silica gel, which adsorbs any last trace of the unwanted fission product. The concentrated uranium nitrate solution stored in this tank prior to shipping is the primary product of Nuclear Fuel Services. Plutonium is shipped by pumping it into plastic cylinders, then placing them in large steel drums for shipment. From the storage tank, the solution of uranium nitrate is pumped into a tank truck. Then the valuable cargo goes to a distant location to be converted and fabricated into new fuel elements for an atomic power plant, such as Consolidated Edison's Indian Point Atomic Power Plant near Peekskill, New York, on the shores of the Hudson River, which supplies nuclear-generated power to the New York metropolitan area. This plant, like many others, has already proved itself as a safe, practical source of energy for economical generation of electric power. In the years to come, atomic energy will produce an ever-increasing amount of electric power, and the commercial fuel reprocessing plant of Nuclear Fuel Services, with its innovative technology, will help make atomic power plants a prime source of economical electric power that offers control of the peaceful atom will continue to expand in the field of power generation, furnishing economical and smoke-free electric power to factories, homes, farms, and the large metropolitan areas of America. Civilian nuclear power is here to stay, and the atom is the symbol of this new generation of energy that is being used at an accelerating pace for the betterment of mankind.
They can repair them remotely now.
That was a problem up at West Valley, wasn't it?
That's
Not
right.
Enough.
They had none of the plant could be repaired remotely, but you know the problem at West Valley was that they operated 4 or 5 years very successfully and successfully reprocessed, and they decided to close down the plant to upgrade it. And when they closed down, the Nuclear Regulatory Commission changed the rules in the middle of the stream on them, and they started adding more requirements and more regulations. And as a result of it, West Valley, the company that owned West Valley, said, gee, you know, there's so much regulation, there's just no way we can afford to do it. So they went out of business.
Do you know if Valley, to wrap things up, are we still having to, the government, taxpayers, still having to pay to clean that up? What's going on up there, and what are we going to get out of that, whatever we're putting in? How much are we putting in, and what are we getting out of it?
Well, in the first place, they did some defense work there in West Valley. So it is, you know, a legitimate cost to the taxpayers because these weapons help keep us safe and free.
How much is it?
I can't tell you the exact amount. I can get those figures for you, but it's been lingering up there. And since I've been Secretary of Energy, I've under the direction of the President, I've been going around trying to clean up some of these little places that are thorns in our side and thorns into the future development of nuclear energy, like West Valley, like 3 Mile Island, that type of thing. So I've put a lot of emphasis on cleaning those up. But in addition to that, we're getting rid of the waste. We're putting it in a form that we can bury, like I said a few minutes ago, and we're getting a lot of experience out of it as to how to handle that, you know, special waste streams such as that. So we're getting a lot out of it, maybe not as much as you would think that we should get for the money it's costing us. But we are paying, I think the state pays 10% and the federal government pays about 90%, I think. But I'm not exactly sure because there was a little maneuvering on the part of the New York delegation there with me at the last, and we went along with a little bit more than they had wanted to put. Or maybe we got them to put in more. That was it. The state of New York put in a little bit more than the federal government. So we can get those figures for you, though.
There always is a little maneuvering. Any idea how long it's going to take to finish that up?
I think they're going to start glassifying 1988, I believe, if I'm not mistaken.
Yeah, I think we better finish this up. I think you've got some other people waiting. Carl, if you can get us... Okay, if you can just get us...
one wide shot?
Well, one wide shot, maybe a...
Go ahead, I'm rolling.
open.
You're not recording anything now.
And so on here.
Yeah.
He's just rolling on some wide
Yeah. It's nice to have an opportunity to sort of talk about them, you know, so put things in proper perspective. It's so simple and makes so much sense to me. I don't see why, you know, other people don't understand it. But a lot of other people, you know, trying to distort what the real picture is, you know, and this is the thing that chagrins you.
These men work at a factory that produces nothing. The nuclear waste fuel reprocessing plant at Barnwell is idle, as it has been since it was completed in 1976. These cooling ponds were built to hold 350 tons of radioactive fuel rods from atomic power plants, but they are empty. The plant was designed by Bechtel Corporation to take 14-foot-long reactor rods like this one, separate the uranium and plutonium from other radioactive elements, then send the uranium to another factory where it could be made into new fuel rods. The used rods come out of nuclear reactors from across the United States. Electric Utilities and the Department of Energy see the Barnwell plant as a solution to their growing nuclear waste problem. But critics of reprocessing say the Barnwell plant would be an economic and technical failure. Their evidence, they say, is the only commercial reprocessing plant ever operated in the United States at West Valley, New York. The owner of that plant, Getty Oil, lost millions of dollars, and taxpayers are now paying more millions to clean up radioactive waste. West Valley was also designed by Bechtel Corporation, and Getty Oil produced this film to explain reprocessing after the plant was opened in 1966, a time when the future of nuclear power was unquestioned.
Spent nuclear fuel elements in ruggedly built trucks and special railroad cars head toward western New York State and the first privately owned plant in the world, built exclusively to recover nuclear fuel for future use. Here begins the story of nuclear fuel reprocessing.
But the story does not have a happy ending. In 1972, after 6 years and $42 million in losses, the West Valley plant was shut down by Getty Oil. Getty's loss was nothing compared to what it will take to clean up West Valley. Left behind were 600,000 gallons of highly radioactive liquid and sludge stored in a huge underground tank. In these pictures taken last winter, you can see the heat from the radioactive liquid melting the snow over the underground tank. And inside the plant are 163 metric tons of radioactive fuel assemblies. While the cooling tanks at Barnwell are empty, these tanks hold 615 canisters filled with spent fuel rods. The utility companies that sent the rods here refuse to take them back, and the state of New York is suing. Unless the demineralized water in the tank is recirculated, cooled, and purified, the radioactive rods would heat the cement tank to 185 degrees. The taxpayers of New York State are paying for all of that. No one knows what will happen to the radioactive fuel rods, but a cleanup of other parts of the plant has just gotten underway. More on that on Tuesday's 7 o'clock report. John Roberts, TV 10 News. Allied General, the owners of the Barnwell reprocessing plant, want to sell it and have said they would not operate Barnwell even if the government were to financially support reprocessing. A vice president of Allied Chemical, which owns Barnwell, says the company really wants out of the business. In that respect, Allied officials are like those at Getty. A Getty executive was smiling the day his company was no longer responsible for the reprocessing plant at West Valley, New York.
NFS no longer will be in possession of the center at West Valley.
That was in February of this year when the U.S. government took control of West Valley and began planning a massive cleanup effort.
Okay, we're ready.
This month, the first small steps of that cleanup were taken as radiation experts suited up and went inside the reprocessing cell to see how much radioactivity is lodged in the cement walls and piping.
This is where reprocessing actually took place.
This is where uranium was removed from the product stream.
The taxpayers of New York State are paying 10% of the cleanup. The rest, 90% of the bills, get paid by the United States government.
Under the direction of the president, I've been going around trying to clean up some of these little places that are thorns in our side and thorns into the future development of nuclear energy, like West Valley.
The cleanup at West Valley will cost at least $400 million. Engineers predict the cost could go to $1 billion. But the use of tax money for the cleanup operation at West Valley was only one issue. Some people who live near there are concerned about safety and health. Like Barnwell, there are farms surrounding the West Valley plant.
I mean, we have to make a living here. If our milk is contaminated and say they come around and say you can't ship any more milk because you've got too much strontium-90 in it, what happens to the livelihood of these people in the area? Has that been considered in this at all?
The manager of the government cleanup promises caution will be taken when 600,000 gallons of radioactive liquid and sludge are removed from an underground storage tank.
Anytime you're working with radioactive material, there is a hazard. If the material gets away, it can contaminate areas. So one of our first priorities, one of our principal priorities is safety.
As the cleanup continues at West Valley this fall, the government is making plans to encourage another try of reprocessing at Barnwell. The Secretary of Energy says he is negotiating with a dozen companies who might be able to operate the plant. The government has offered to buy the plutonium that would be produced at Barnwell.
We need the plutonium for our research programs. We need it to fire our breeder reactor. Now, what price do we set on that, and how much are we willing to pay for? You see, we need it, so let's set a price on it, and that would also make this whole reprocessing bit a viable commercial venture.
But critics of reprocessing say the Barnwell plant would be a financial and technical failure. More on that in our next report. John Roberts, TV 10 News.
In Barnwell, a $350 million factory sits idle behind a row of pine trees at the end of a country road. The Barnwell plant was designed to salvage uranium from used nuclear plant fuel rods. John Roberts is with us to tell us more about the Barnwell plant and to wrap up his series on reprocessing. John?
Susan, the reprocessing technology was tried once before by a major American company, but that venture in New York State was eventually shut down. One of the problems was maintenance and the need to hire hundreds of workers to maintain equipment in areas of the plant where they'd be exposed to high levels of radioactivity. The reprocessing plant at Barnwell was built to do the same thing as the defunct reprocessing plant at West Valley, New York. Chop up nuclear fuel rods, dissolve them in acid, then separate uranium and plutonium from other radioactive elements. It's all done behind thick concrete walls and leaded glass because the gamma and beta rays emitted by those elements can cause cancer and genetic damage in plant workers. Remote control arms are used to repair equipment behind the thick walls so workers will not have to be exposed to radiation. But at West Valley, workers had to be sent inside areas contaminated by radiation to repair equipment. Because each worker is allowed to absorb a limited amount of radiation, hundreds of temporary workers had to be hired to do maintenance at West Valley. A report commissioned by the Department of Energy says Barnwell does not have enough remote maintenance equipment. Because of that, Argonne Laboratories concluded that Barnwell could suffer the same fate as West Valley and give the industry a further black eye. The first serious contamination at Barnwell might require the entire plant be written off. The report was leaked to the press this year, but the Secretary of Energy says its findings are not valid.
People say that if this plant breaks down, you have to close down the whole plant. Well, that's not necessarily so because we can close down parts of it, remotely repair it, and then get it to working again.
And the president of Allied General, owner of the Barnwell plant, says more remote control equipment is not needed at Barnwell. He says workers will not have to make contact with radioactive areas because equipment in those areas will not break down.
But we aren't planning on doing any contact maintenance if we can help it, because the only places where that would ever be needed are places where maintenance does not appear to be required at all.
Dr. Buckham says he thinks the Barnwell plant will be economically feasible because it was designed to handle 5 times more nuclear waste than the plant at West Valley. As of now, the Barnwell plant relies on government research grants to pay employees and maintain the equipment. Nuclear engineers at Barnwell say the experience with reprocessing at West Valley, New York, provided valuable lessons about nuclear technology. Critics say West Valley was a failure which the Barnwell plant could repeat. Whether or not West Valley was a learning experience, there's no doubt about who is paying for it. The taxpayers are picking up the tab for a cleanup that will take 15 years and cost up to $1 billion. The issue now is whether the nation should spend more money on reprocessing. As we heard from U.S. Energy Secretary James Edwards, the Reagan administration is serious about getting the Barnwell plant into operation, and it wants Congress to guarantee $250 million a year in business for Barnwell. And the issue facing South Carolina is whether a reprocessing plant would be a good thing for the state. It could mean up to 3,000 jobs, but on the other side of the coin is the track record of reprocessing at West Valley, where the state of New York ended up with tons of highly radioactive nuclear waste.
Thanks, John. Still ahead this evening, South Carolina